Okay, okay. So today, just tried on this one. Yeah. Okay, this point is 8. There is 6 ohm resistor. Here comes the 12 ohms. Then it is 1 ohm and 2 ohms. The question is find equivalent resistance between A and B. So in this case, last time we learned few methods. So now today we'll learn point potential method. So what is point potential method is, they say it now, find the equivalent resistance between A and B. So
Yes.
okay, so what we considered is, we just consider like this, a battery between A and B. This is okay. So now this will be
Yes.
plus V, this will be 0. So in this case there is nothing, na? There is no resistance, there is no other element. So this will be voltage V, this will be 0, correct? 0 volt. So this is at higher
Yes.
potential, this is at lower potential. Okay, now let's try down which other places this is 0. Over here there is a resistor. So, but in this case, this is 0, this is at 0 potential, this point is also at 0 potential. Same thing, this
Yes.
point is also at 0 potential. And
Yes.
if we consider V, then this point is at V potential, this point is also at V potential, this point is at V potential. Hope you
How?
are, because there is no element na, over here. See, there is no resistor, there is no inductor, there is no capacitor, nothing.
So it should be at zero, right?
But okay, this is a, see, 0 you understood, this was 0. This you
Yes.
understood how it is 0. This point
Yes, there's nothing there.
over here, this point 0. This much is,
Yeah.
this is also clear now. This point is clear, 0 how it is.
Yes.
Now I am going, now this is at V potential. So this point will
Yes.
be at V. This point will be at V. This point will also be at V na. If we consider this line, this point I have considered, A point I have considered at V potential, because see, pay attention, this is a cell. So this will be at V potential, this will be at V potential.
Yes.
Clear now all the part.
Yes.
So there is no point other than this, means there is just one potential is V and 0. Okay, all the points are covered. So let's take V and 0. Now let's simplify this thing. This is 4 resistor. It's in series. Okay. The 4 ohms. Okay. So this is done. Now the next one is this. This is also between V and 0. So, but okay. So this is second resistor. 1 ohms. So this is also done. Now V and 0, there is one more resistor of 12 ohms. V and 0, there is one more, and there is one more of 6 ohms, and there is one more of 2 ohms. All the resistors are, this V is at the point A and 0 is point B. Just solve it and get the answer.
But 4, 12, and 6 are in series.
Which one? 4?
4, 12, 6.
4, 12. How can it be in series? There is a line now over here. This is a different potential.
Okay, yes.
Understood? So because the potential is different, the current will be different.
Yes.
So just solve this and get the answer.
Hmm. 13 by 12.
No, a little mistake. Just solve it again.
25 by 12
Even now also it's a mistake. So
plus
12, 12
1 by
only
1,
will be the
1 by 4, 1 by 12,
18 and 6, 24 by
2.
12. 2 ohms is the correct answer.
Yes.
Just write down the next one.
But why did we need the point potential method? Couldn't we have done that normally?
How you will do normally? Just tell me.
Draw it as a circuit which is, and then find all the parallel lines, add them up together one by one, then
But
make
you
it a
should know na
series
ki
and
which are the points of same potential. Then you will apply na ki this has to be parallel or this has to be series. If this many resistors are there, then see this you can't logically you can't tell na ki how you will tell this ki simplify in this question. How you will simplify? You can't see parallel series directly until and unless I check the potential. Then we can check that this are at same potential, so this can be considered as the same point.
okay.
Okay. This many resistors are there and very see why when we'll use point potential is when we have many resistors. 5, 6 resistors and we can't find anything. Series also we can't check and parallel also we can't find it out. So at that point now we will apply point potential method.
Yes.
Okay. So basically, there are many this thing in IJSO. Na, they ask circuits like this. So you should. So I have taught you 2, 3 methods. First is this one point potential, Wheatstone one. When there are 5 or 6 resistors, you can also do by Wheatstone bridge.
Yes.
Okay, and then I taught you that one folding method, symmetry and parallel perpendicular symmetry. So these
Yes.
are all the methods of solving complex circuits.
Yes. The second is a Wheatstone bridge.
Yeah, Wheatstone also you can do, but now today, now because there are many questions of point potential, so I think it would be better if you do by point potential.
Yes.
Yeah, Wheatstone only this will happen because I think everywhere there is a resistor, na? So
Hmm.
uh, this point will is totally a different thing. So I'm considering a X and X. Yeah, so this will be in the form of Wheatstone. So just try down. This is as I yesterday I told you na A, then we'll do like this. This point is X and B. So X and X there is a common line. A and X there is this resistor. A and X it's R. Again A and X there is one more resistor R. So this is included. Now this now X and B there is one more resistor. So I am including this. A and B also there is one more resistor. So this and this is on top, and X and B there is one more. So I think all the resistors are included.
Yes. Yeah, it's a Wheatstone so that X and X gets ignored.
As such, there is no
Then
resistor between them. So yeah, it is ignored. So now A,
there are three paths. So
Yeah.
3 parallels,
So 2R,
1 hour and 2 hour.
R and 2R. Just
Yes.
complete that question.
Half.
R by 2 is the correct answer, no?
Yeah.
Okay, perfect. That's correct. So let's jump to the next one. Now, just try it on this one. Okay. Actually, I should have drawn the circle first, but that's fine. Okay. Question is saying find equivalent resistance between A and B.
A is inside the circle.
No. Yeah, A is inside the circle. It's not on the circle.
Okay. 4 hour by 3.
1 minute. Let me check this. 4R by 3, what now?
Yes.
Okay, 1 minute. I'll check that. Just try it on this one. In the meanwhile, I'll check that question also. This is R, this is R, and there is one more resistor R, and this point is B. So this in this case, the answer. Okay, 1 minute. This has to be in B potential. This is zero. This is zero. This is zero. This is zero. Okay. A or B potential. And this will be X. Okay. So in this case, the equivalent resistance between X and B will be R by 3. And between A and B, yeah, the answer is 4R by 3. Correct. I am considering a cell over here. This is at V. This is so. This will also be at V. This point will also be at V. Okay. This is 0. This point is at 0. This point is at 0. This point is at 0. Okay.
How do you decide which points are at V and which points are at 0?
Generally, that I will explain when there are more. But in this case, just consider a battery, na, like this way. So this will be at V potential. This will be at 0. A will be in this. This is very easy one. So in this case, you consider A as your V potential and B as your 0.
Even if you consider the battery, how do you know which points will be V and which points will be
Higher
0?
higher potential will be at V, na, and lower potential will be at 0. Then only that battery will be of V voltage. Clear, na? Or any doubt?
Uh, so the parts which are lower, like near B, they are 0, and the ones which are at the top near A are at V.
Yeah. See, this will be at higher potential V. This will be at 0. So there is nothing, na? There is just a common this thing line. There is no
Hmm.
inductor. There is no circuit element. So this will be at 0.
Yeah.
This will be at 0. So this all will be at 0. Okay, this point we
Hmm.
have to consider something. So I am considering it as X.
Okay.
So now there are 3 points V, which is A at V potential, and 0 at B, that is B. Okay, so there is one resistor, it's done. This is B. V2, okay. This is also 1 point. Okay, this will be Y. Okay, 0 to Y. Okay, if there are four points now, then we have to consider this by your original one. See, there are V, now 0, X and Y. So let's do like this. B, X, Y, and 0, which is B. This is point A. Okay, so A to X. Yeah, this resistor is included here. R here. X to Y. Okay, there is one more resistor. ये वाला भी include होगा. So it's R. Next is
How
Y.
do you form a Wheatstone bridge?
See, like this. Pay attention. This this type. If there are 4 points, no. So you consider like
Hmm.
this: A, X, Y, B, and then put the resistors. So Y to 0, it's again R. So this is included. Y to V, Y to B, this is also included R. So now I think all are included. Now only this is left. This is X to 0. Yeah, this is also R. I think all are included now. Now just have to use. This will be balance Wheatstone bridge का condition. Na? P,
Hmm.
Q, R, S. So P by Q, P by R, sorry. Okay, 1 minute. P by R equal to Q by S. So this will be eliminated. हो गया ना 2R by 2R. Answer is R. एक और कोई पे पॉइंट है क्या A to B V20 भी है. This is V20. How we have included this one? How many register? 1, 2, 3, 4, 5 and 6. How many we have? 1, 2, 3, 4, 5. एक कहाँ गया? एक मिनट. So V2X is R. ये वाला डन. एक और बचेगा. This one. There is one more resistance R. आ रहा है कि should I do it again?
Do it again.
Okay, 1 minute. Okay, okay. So I think let's do it. This question, this is fine, na? This is proper. So as I told you, A, X, Y, B. This is at 0 potential and this is at B potential. So now let's consider A to X or V to X. So this is included. So this I am doing cross now. This is included. Okay. Clear, na, Ishan?
Yes.
Okay.
Yes.
Now X to B. This point is B only. So this R. X to B. Okay. This is R.
Which is the X, the one at the topmost quadrant, or
This
there are
one is,
two?
this is X, na?
No, in your diagram, in the actual diagram.
In the actual diagram, this is X. This potential is X. So this is X. So this will also be X, na?
Okay.
Okay. Should I use another pen or this is fine?
No, it's fine.
Okay. So this is done. This resistance is also included. Now X to Y R. X to Y R. Yeah. Okay. So this is also done. X, Y,
One.
this resistance. Okay. Now Y and A point R. Y and A point R. Okay. So this is also done. So four are done. Now Y and 0, this one. So this is Y and B. This is also included. Now there is one is between A and B. This is V and 0. So between A and B. So like this is R. Hope the diagram is clear.
Yes.
Okay. So this is the condition for balanced Wheatstone bridge. So this has to be removed. So now the diagram will be like this: A R plus R 2R. There is one more resistance which is R, and there is one more resistance R plus R which is 2R parallel. Clear or should I draw it again?
No, I got the Wheatstone part. You decided that to be X, the potential to be X because the
There is a
resistors have come in the middle.
yeah. So there is a resistor. So this won't be at same potential, na? This is
Yes.
so this I have to name it separately.
V is equal IR.
Yeah.
Okay, got it. I'll
Okay.
just copy it now.
Yeah, yeah. And when there are 3 4 points, then you have to understand that even with the point potential, you won't be able to solve because there are 4 points. Then you will apply Wheatstone.
Okay.
if after point potential you are getting just 2 or 3 points, and you if you can see कि यार ये तो series parallel हो रहा है, then it's fine. अगर वैसे भी नहीं हो रहा है, then apply these two.
Yeah. What's this method called?
Point potential method.
Okay.
That at any point you considered as a potential, and then
Yes.
okay, yeah. So this is known as point potential. Just write down the next one. Should I rub this part now?
Yes. Mm, mm,
Easy or tough?
Normal.
Okay, okay. Yeah, once you will practice now this. So we have done the basic circuits questions. All the methods we have learned.
Yes. Mm, mm.
Again, we'll consider battery kind of thing where this will be at higher potential. So this will be V. This will be 0. This will also be at V potential. This will be at 0.
But then at the middle point, it can go by the other wire, right?
Which one?
Middle point of the diagonal.
This one.
It can. Huh.
This no you are talking
Over.
about. This is parallel,
Yes.
na? So you can. I've taken this as a parallel. This is a parallel thing.
So the current from there can't go to the other diagonal.
No, the current can't go from other diagonal. It's
Okay.
going parallel.
Okay. Mm,
So R equivalent between A and B will be 1 by 2R.
you'll also have 1 by 4. You'll also have 4R.
Which one?
0 to A to B.
Z-
OAB.
This is A, this is B. Okay, let me verify. This I have
No,
included.
not that 0. The upper right quadrant to A and then B.
Okay, I'm not understanding. Okay, like that way it won't be upper right. This one, this zero.
Yeah, that.
Okay, so this and which one? This one.
Yes, and then it goes to B like this,
Okay, so I
sideways.
have taken the parallel. एक ये हो गया. So this is included. Then this is also parallel. This is also included. Then this is also a parallel. All are parallel to each other
Okay.
because all follows a different path.
Yes.
So all are parallel to each other. So it is 4 by 2R, which is
Which is the last two are for? Okay, got it. Yeah, correct. Hmm.
RAB will be reciprocal of this. So it's 2R by 4, which is R by 2. Even today we'll do the proof also of Wheatstone.
Of which square?
Of Wheatstone, yesterday we derived, na?
Okay.
So we'll do the proof
Yes.
also today.
Yes.
Done?
Yes.
Okay, okay. So one will practice that infinite also. So let's check whether you are able to solve that also. Na? This is A, this is R, this is P, and so on. It goes up to infinite. So from here it forms this thing like a pattern.
Yes.
Okay, so this resistance, because if I eliminate one, as such, it won't affect the resistor. So it's A.
I got x square r minus x minus r is equal to 0.
X square. You got like this form.
Minus x. I got x square r minus x minus r.
Okay,
I didn't
so
get x square
this
plus
only has to
r.
be the answer, no? Because see what happens in this case. This will be in series. So A, B, this will be R, and this
Yes.
will be X plus R.
X.
This will be in series, no?
How?
There is no this thing, no? Because this I've considered this whole. If I from infinity,
X.
if I remove this part, it won't affect the
Okay,
resistance, no?
so you took that r. Yes,
So
got it.
this from here, it would be X. So the
Yeah, I
first thing,
can.
yeah, understood. So this part will be
Yes.
X. This is X. When X plus R, then RAB I already took as X. So the parallel combination of this will be equivalent to X. So X equal to R into X plus R upon R plus X plus R. So now just solve this. X will be what? Ax square plus bx plus c equal to 0 minus b. So minus r plus minus under root of b square minus 4 into 1 into minus r square 2. this is wrong because negative, it can't be negative. So the answer would be minus r plus root 5r by 2, which is r common root 5 minus 1 by 2. Clear?
Yes.
Got the answer?
Uh, almost.
Okay, okay. Take your time.
Yes.
Okay. So now let's jump to the next one. Now in this case, find current. You have to find the current in this.
Okay.
I think, but by we'll take the help of point potential only. So slowly I will
Zero
increase the
point
length.
five.
Yeah, yeah, that's correct. So this is 40. Pay attention now, and this is 0. So whenever there is a
Yes.
lower terminal, na, you always consider this as 0. So this is 0. But when the
Okay.
questions will become complicated, na, then now this is 40. This is 0. So now
Yes.
V equal to IR.
Yes.
Delta V equal to IR, correct? So delta V is change in V. So it's 40 minus 0 is equal to I into 20. So in this case, it was simple. So it's 2 amperes now.
Yeah.
Clear?
Yes.
Should we just write on this one? Current in each resistor you have to find out.
Okay.
So see, in this you have to precisely choose properly when there is no resistor or something. No, choose that point bit as 0. So in this case, just pay attention. Yeah. So then this case, I think this is
It
the perfect
gets 4 volt. Yeah.
Yeah, in this case, I'm choosing this as 0 because see, if I consider this as 0, na, then there is a resistor. So if I consider this as 0, here it is a resistor, na. So Now pay attention. One question. Let me explain you with point
Okay.
potential. So this is 0. So this will be 2. This will be 2. This will
Hmm.
be 2. Okay. Pay attention now over here. This is already 2. This is 0. So then this point will be minus 2. Clear or bouncer?
How minus 2?
Because this is at positive potential. Na? So if, okay, pay attention. Now this is minus 2, then this is minus 2. Then this is 0. Then only this will be 2,
Yes.
na?
Shorter side is 0, right?
Longer side. No, in this case, see, first I've considered this is the first step. This I've already
Okay.
considered this is as 0 potential. Okay.
Okay.
Okay, I haven't considered this as 0. You can choose anything as 0, but I haven't considered because there is a resistor over here. This point there is no resistor, there is nothing. So I've considered this point as 0.
Okay.
Okay, so then this will be 2. This will be 2 potential, correct?
Yes.
So this will also
Yes.
be 2. Okay, now when we go to the negative side, this will be minus 2, na? Then only this has to be 0. This I have considered 0. So this has to be minus 2, na? So then only this will be 0. Minus 2
Yes.
plus 2 minus 2 plus 2. This will be 0. Hope this part is
Yes.
clear.
Yes.
Okay. Okay. So now what should be the next step? This is minus 2. This has to be minus 4.
Uh, it's minus 2. Then even that 2 volt you're taking as minus 2 instead of plus 2. Yeah,
Which
it's
one?
minus 2. Yes. So as you go to the right, it becomes negative.
Yeah, it becomes negative because once we consider this as 0, na, and on that side it becomes negative.
Yes. Okay.
Okay. So now how will you do it further?
Minus 4. So V is equal to IR. You know V is minus 4. R is 1. I is 4 ampere. For
Yeah.
that resistor.
Yeah.
Then like that for this one also. Minus 2. So current is 2 ampere and here it's 0. So current is 0 ampere.
Where how you did it? Yeah, it's correct. The assumption is correct. Good.
Yeah.
So how you did it? So
So
this is
first
2.
at
Yeah. Tell me.
the outermost ampere, the outermost
So
resistor,
this, yeah, yeah. So this
their
has to be
voltage.
0, correct? This has to be 0.
Yes,
This will be minus
yes,
2 and this will be minus
yes,
4. So the it is
yes,
at same potential. So the current over here, because it goes from higher to lower, na? So it's same potential. So I is 0 in this case. In this case also I is 0, and in this case also I is 0. So the current is 0. Good. Clear or tough?
uh how did you know that even over there, even on the other side, it will be same minus 2 only?
See, this is now how we did over here. We once we consider one potential as 0, then on the right side this has to be minus 2, na? So minus 2, then this will become 0, na? So if one potential you
Yes.
know, na, then other you can determine. On the other side you can determine.
Okay. Yes.
More questions will practice, you will understand it in a better way. So let's jump to the
Yeah.
next one. This question, okay, one second. Okay, yeah, first we'll do this one. Find the in the
Mm-hmm.
circuit shown current through 25-volt cell is. So you have to calculate this.
Okay. Can't we do it like total voltage and total resistance, like total voltage into is equal to current into total resistance?
See, you can do it by any way, but if you find that way easy, you can do it. No, that's not a problem. This is not the one way, but I just wanted to explain you this way because this becomes very easy when the circuits are complicated.
Yes. Okay. So 10 volt. So voltage.
But don't consider zero where there are resistors. So where there are resistors, not don't consider. So I think this is a better point to consider zero because there is no resistor over here. So this I am considering zero. Okay. So
Okay.
this will be minus 25. This will be minus 25. This will be minus 25. Minus 25. There is no resistor only.
Yes.
Okay. Let's go further. So this will be again 1 minute. Huh? This will be again 0, 0, 0, and 0.
Yes.
Now if this is 0, then this will be minus 10. If this is 0, then this will be, okay, this will be 0 smaller, then this will be plus 5. If this will be 0, this is 0, this will be minus 20. Higher
Okay.
potential is at 0, then lower potential will be minus 20 na, because potential difference they have given is 20 volts.
Yes.
This is 0, this is minus 30. Okay, 1 minute. Wait. This will be plus 30, sorry. आ रहा है कि बाउंसर जा रहा है?
Yes.
Okay, this will
Correct.
be 0. Total potential difference is higher potential is at 0, then lower potential will be minus 25.
Yes.
Now, no, current through 25-volt cell ना?
Hmm.
Okay, तो कैसे करोगे?
V is equal to IR.
Yeah, so just
V
calculate
is
na. Just calculate the current at each side. So let's calculate over here. This is a higher potential is minus 10. This is the higher
hmm.
potential. This is the lower potential. So it's let's consider over here. Let's find out the current at this point. So it's minus 10 minus of minus 25 is equal to I
15.
into R. Clear? So it's
R is
15.
3. I is 3.
I is 3.
Yes.
So this is 3. So we got and the current will always flow from higher potential to lower potential. Correct, na? So this will be the
Yes.
direction of current. We got the direction of current also.
Downward.
Yeah, downward. So this is also 3
Hmm.
ampere. Okay, because there is no resistor or something, तो वहां तक पहुंच गए 3 ampere. Okay, now okay over here also we'll calculate. The higher potential is 5, lower is 5.
Negative 25.
Okay, 1 meter. 5 minus of minus 25 is equal to I into 10. So 30.
30. 3.
Again I is 3. Okay, but it would be from higher to lower. So यहाँ पर भी 3 आ गया. Okay. Now, what would be this one then?
What would be? Okay,
Uh,
the next one will be 20 volt and minus 25. Minus 20 and minus 25. So 5. 5 is equal 5 ohm. 5 ohm into I. I is 1 ampere.
So 1 ampere like this way.
Yes.
Next,
11. 30.
yeah,
Plus 30 minus 25. 5.
yeah.
5 by 11 in the opposite direction.
This is higher potential, na 30. So this
Yes. So
direction only.
over there. Upward.
Yeah.
But 30 is the greater. Yeah.
So what will be the answer? 5 ampere.
Uh, 30. Hmm.
1 minute. So 30 minus of
5
minus
by
20.
11.
30 minus of minus 25. No, okay, I made this thing. Wait a minute. Yeah, this will be plus 30 and this is 11. So 30 is equal to I into R. R is 11. So 55 is equal to I into 11. So I equal to 5 amperes. So this is 5 amperes. Now let's apply. अभी KCL apply करना पड़ेगा ना, because when there is, KCL, Kirchhoff's current law.
Yeah.
So what is that?
You can add them up. The currents.
So so let's apply KCL at junction A. This one. So what?
Hmm.
So all incoming currents will be considered as
Positive.
okay. So plus three. This is plus three. Correct. Easy or
Yes.
tough?
Yes.
This
Medium.
is plus three. This is plus three. So this I am considering plus three, and this is outgoing. So minus here. Should I write I? So we'll get. एक minute, yeah, this is I A. So I minus I A equal to 0. So I A will be 6 amperes.
Hmm.
So we got this as 6 amperes. उसके बाद अभी KCL at junction B apply करते हैं. So plus
Eh,
6
yes.
plus 1
Hmm.
minus, yeah, this is
IB.
IB. Yeah. So minus
7.
IB equal to 0. So IB equal to 7 ampere. अभी वापस
Yes.
उधर, तो इधर आएगा IC will be 12 ampere. This is C, junction C. So IC will be, okay, KCL at C. So it's 7 plus 7
5.
plus 5
Yes.
minus IC equal to 0. IC will be 12
12.
ampere. So the current through this will be passing through this will be 12 ampere.
Yes.
Tough or easy?
Medium. Yeah.
Okay, okay, yeah, but a little, but I think there is, I just wanted to this thing. It's easy only potential, but yeah, when it comes to current and all, then it gets complicated. So let's see one more question. Yeah, just try out this one. Find potential at B.
Shall at B.
This point.
Yes. Okay. 2 volts goes to 2 volt. 2 ohms. V is equal to I. 1 ampere downward.
अब इसको कहाँ पर जीरो करे? So I think let's keep this as 0. इसको जीरो करेंगे, दिस विल बी जीरो, तो दिस विल बी एट हायर पोटेंशियल, ये वन आएगा, तो दिस विल बी 1 वोल्ट। आई थिंक इसमें केवीएल भी अप्लाई होगा, दिस विल बी मोर कॉम्प्लिकेटेड, इसको अभी स्किप करते हैं, बट इफ वी डोंट
Okay.
लर्न दिस ना, तो फिर प्रूविंग नहीं होगा। ओके, सो लेट मी ट्राई तो करते हैं, सो दैट वी कैन प्रूव आल्सो दैट पार्ट, व्हीट स्टोन वाला। सो लेट मी एक्सप्लेन यू द फॉर्मूला। एक दो ही क्वेश्चन है, तो लेट्स डू इट ना, चलेगा, फिर वो प्रूव भी हो जाएगा। सो द फॉर्मूला यू कैन डू लाइक दिस, वी ए माइनस वी बी इज इक्वल टू माइनस ऑफ KVL from A to B. Okay, so like this, we have to solve this kind of questions. Okay, तो अब पाथ क्या चूज करेंगे? आई थिंक दिस, बिकॉज इधर तो सारे अननोन्स है, रेजिस्टेंस, दिस इज अननोन, दिस इज अननोन, सो विल चूज द पाथ फ्रॉम दिस, लाइक दिस टू दिस। एक मिनट, नहीं, इधर भी अननोन है, सो दिस, दिस, एंड देन दिस। Voltage na, so VA is what we have considered this as zero. Voltage at B we have to find out, so I think VA minus, okay, we'll apply first, बाद में करते हैं, minus what is, see KVL, what does it states कि अगर if you go from lower to higher, lower से higher जा रहे हो, your path is like this, first you choose the path, हम लोग ने path choose कर लिया, okay, we are going with this path, आ रहा है ना समझ?
Yes.
Yeah. So this path, then we are going like here, and then we are going like this. This is the path we are choosing. Okay. So see, KVL क्या बोलता है कि if you go from lower to higher potential ना, while you are going to this path, you are going from lower to higher potential, then consider that voltage as positive. तो ये +1,
If you are going as what?
lower to higher.
Okay. 1 volt to 2 volt.
नहीं
Yes.
नहीं, not 1 वोल्ट to 2 वोल्ट, इसमें lower terminal, see your path is like this, and this comes like,
Okay.
first comes
Yes.
lower potential, then comes higher potential, then you have to consider that voltage as plus volt, plus V. Suppose if I'm going, my path is like this, and we are there comes a higher potential first, and then comes a lower potential, then you consider minus V.
Yes.
Understood? So this will be +1, this will be -2. So +1 and -2. Hope this part is clear.
Yes.
So KVL, and then just consider the resistance part. Na? So the resistance will, ये रहा +1 ampere, V equal to IR. Clear? So मेरी डायरेक्शन भी सेम है, and resistance is also same. So V equal to IR. Apply this ना, तो 1 into 2 कितना होगा? Plus IR. So it's minus
Two.
+1 -2 +2, -1 volt. So VA minus VB equal to -1 volt. 0 minus VB equal to -1. VB equal to 1. Potential at B is 1 volt. आ रहा है कि बाउंसर गया?
Uh, from where did you get current?
Current they have already given ना, ये रहा 1 ampere.
Okay. And
Okay,
V
so
how
this
is
is,
VA 0? Okay. Yes. VA is 0. So you assume that to be 0, but that's an assumption, right?
Which one?
VA is
Ah,
0.
VA is 0. That's the same point potential. It's I've assumed this to be 0. So this will be V volt.
Okay. Okay.
Okay. This will apply in proving also. To prove that, no, we have to prove.
You could have assumed B to be 0 also, right?
But B तो हमको find out करना है क्वेश्चन में. They said ना.
Okay, yes. Yes.
Clear?
Yes.
Okay. So I have also applied KCL also at C. So 1 minute. So KCL में क्या था? Plus this is incoming. So +1, -2, -1. Oh, okay. That we have to find out. So plus I think IC will be 0. So IC is equal to 1 ampere. Understood, na?
Yeah.
So over here it's 1 ampere.
Yes.
Just tried. ये वाला से अच्छा है first. Let's do because that is important. Wheatstone का derivation कर लेते हैं. This much is not
Okay.
needed. मत बहुत टफ हो जाएगा. अभी फिलहाल आपको we don't require. Only basic point potential one we require. उसके साथ current के साथ अभी. Okay. So Wheatstone ना. So let's draw the diagram first. A. This is at V. Okay, 1 minute. So let's draw this one. What we consider this is R1, this is R2, R3, R4, R5, and this point is B. So now apply the point potential method. Now see what we will assume कि there is no current through this. We'll assume and we will prove this. We'll prove to prove that R1 by R2 will be equal to R3 by R4. Clear, na?
Yes.
Just try down. Point same apply point potential. This will be at V volt. Let's consider this as this will be 0. Just apply point potential and try to solve it.
Mm. We have to prove R1 by R2 is equal to R3 by R4. Is that given to us?
That we have to prove. I've already taken the current through this is 0.
Okay. So if current is 0, then V at there is also 0.
Yeah. So in this I've taken that there is no deflection. So this is the case for balanced Wheatstone bridge.
Yes. So the point of both at the lines, both of them at the bridge, both are 0 0.
Yeah.
So
Or you can consider it
and
same potential also. So X
X and X.
because already we
Okay.
considered this as 0, na? That's why.
Yes. So then we know at the start it's V. So V minus x is equal to I into R1.
Perfect. Good. This is equation 1.
And V minus x again is equal to I into R2.
Perfect.
So we can say that, what do we
I
have to?
I2 now this current will also be
Yeah,
different.
it's different.
So in this case, let's consider this as I1. This will be I2.
Yes. Now
As
you
there is no
can.
current over here, so here also I2 and over here there will be I1. बस वहाँ तो
Yes.
potential drop हो नहीं रहा है. So
So I2, I1. Then potential is dropping there also. There the potential is 0. So
yeah,
we can say x minus 0 is equal to I1 R3, x minus 0 is equal to I2 R4. Now you can divide 3 and 4.
yeah.
You will get I1 R3 by I2 R4 is equal to x. And then you can divide
Is equal to
x
1, na?
by
X
x.
minus 0.
X by x. Yes. 1.
So
And you can say that you can divide the 1 and 2 also. You'll see 1 is equal to I1 by I2 into R1 by R2.
so I
So,
got this relation. This you got?
yeah,
Okay, same thing now you divide 1 and 2. So you will get
I1 by I2 R3 by R4 is equal to I1 I by I2 R1 by R2 I1 I2 cancel R3 by R4 is equal to R1 by R2.
so you got this both.
Proved.
This is also first relation, this is second. Yeah. So R1 by R2 is equal to R3 by R4. This is the
Yes.
condition.
Yeah.
Clear, no?
Yes.
Okay, wait. Now, uh, there was one question only that was pending. So I think अभी वो कर लेते हैं. At least we'll try down. इतना complicated तो है ये because अभी KVL और KCL की भी practice करनी है. But I think let's try down now.
Difference between A and B is A is going through 2 amperes,
So same thing
6
as I
ohms,
told you,
12
VA
volt.
minus VB is equal to minus of KVL.
Yes.
You know KVL KCL का practice किया है पहले? Because IJS में
Not
they
really.
okay, but they taught you.
Yeah, they taught us.
Yeah, yeah. So even I had seen, but I thought, okay, let me clarify with you that we want to study, na, that part.
Yes. Minus KVL
So it's minus KVL from A to B. So
A to
apply.
B. That is minus 12 volts. Minus 12 volts plus 4 volts.
So we are also, yeah, that will be minus 12. 2 into 6. But
Yes.
okay, so we are also moving from A to B and the current is like this. So 2 into 6 minus 12. Again, now
Plus
it's
IR.
from higher to lower. Na?
Yes.
So what will write? Minus 12
Why minus 12 again?
for this voltage. When we go from lower to higher, then it's positive. When we go from higher to lower, then it's negative. Na? See on top
Yes, but
how we did.
yes, I got minus 12, but why twice?
One is for IR. One is for IR.
Okay.
Okay, this one. 2 into
Okay,
6.
section 2 2. Ah, right.
12. So this one is for this part, one is for this one. Next is what will be the current through this?
Current through that V is equal to
So
iron
इसके लिए फिर
maybe
point potential भी apply करना पड़ेगा side by side.
12 by 9.
How 12 by 9?
V is equal to IR.
Okay. Okay, but nahi, there is a potential difference na. So what will be the current then? Okay. The potential difference so सीधा apply करो ना because this is the same 2 ampere same current will flow ना तो यहाँ पर भी 2 ampere so 2 into 9
Okay.
so which is minus 18 2 again from lower to higher so it's plus 4 lower to higher
Yes.
and then it's again 2 ampere it will flow so it's minus 10 just simplify this part.
Why is the IR minus always?
When we move from potential and if the current is also in the same direction then there will be potential drop na IR so that's why we considered as minus 12.
Okay.
Okay, I think KVL ka we will have to practice KVL KCL and all.
Minus 8 minus 14 minus 48.
Yeah, minus of minus 48 or
Yes, minus or minus 48.
so
So
that's
48.